Okay. Compound interest problem. This just becomes a problem like the ones we were doing previously, an exponential equation or a logarithmic equation. So it just has a story problem that goes with it. So it gives you a little more application to it. Let's say you somehow run in $25,000 and you're just going to invest it all into a CD or something where you're going to make a little bit of interest on it. So invest 25 grand at 3% APR. That's an annual percentage rate. Okay, that's for the entire year. You get 3%. Compounded bi-weekly, which means every 2 weeks. How long until your 25 grand has turned into 35 grand with it just doing nothing but gaining interest? Okay, so this is your compound interest type situation. You'll want to have this formula down in order to do a problem like this. Okay. A is your final amount, P is your starting amount, R is your interest rate as a decimal, N is the number of times compounded in a year, T is time in years. Okay? So you have all the information except for T. Yep. So what's A? 35 grand. What's P? 25 grand. What's R? 0.03. What's N? 26. So this would be my setup.
If you wanted to, you could just put like 7 equals 5.
Where?
Like, instead of 35,000, you should put like 7 equals
Sure.
5.
Yeah. Because either way you're going to divide
Yeah.
and get the same decimal over there.
Yeah.
Okay. So this actually is a problem very, very, very similar to the first one you did today. Same process you're going to go through to solve. You want it to say something raised to your variable equals a number. So there's one thing we need to do first. Careful, not subtract in this case because that's not being added. Divide by 25 grand, okay, and you get 7/5 or 1.4. Yes, okay. And I'm going to go ahead and add that. And yes, I am going to write out all those decimal places. So 1.4 equals that 1 plus 0.03 divided by 26 decimal that you see there raised to the 26t power. Derek says log it. Why? Get the exponent out of the top so we can bring the exponent down. Okay? So I'm going to log both sides. Just because I'm running out of room, I'm going to write that right here. I'm going to log both sides, because then I can bring the 26t out to the front. So now I have the log of 1.4 equals 26t times the log of 1.0011538462. And at this point, what would I do to both sides? I divide by the log of that decimal. And after divide both sides by the log of that decimal, then what would you do? Divide by 26. And I get about 11.2 years. You guys get that? Yes? No questions? What do you got on that? If it said compounded continuously, what would you use? A equals P times E raised to the RT power. So if it says compounded continuously, you would use APERT. If it says compounded monthly, or compounded daily, or compounded biweekly, okay, or compounded quarterly, you use this. Okay with that one? Okay, move on then. Silly question, but it's a question that I've had to ask or answer before, okay? And I want you to think about this. Should I use a compound interest formula for this problem? It has nothing to do with compound interest, okay? So don't use that. Compound interest is a special type of exponential growth, okay? Compound interest is an exponential growth formula, okay? All exponential growths follow y equals a times b raised to the x power. Okay? So that's what we'll use here, y equals a times b raised to the x. What's the a value? 6,000 is your starting amount. Okay? And the b value is called the what? You remember the name of it? It's the growth or decay factor. Okay? It's the number you're multiplying by over and over and over again to figure out your new amount. It's your growth or decay factor. Okay? So, you guys were correct in saying that A was your 6,000. Okay? B is our growth or decay factor. Is it going to be a growth or decay? Decay, because we're decreasing by a percentage annually. If you're decreasing, how do you figure out your B value? 100 minus that, 2.6. 100 minus 2.6, 97.4. Yep. So what's our B value? 0.974. What if I was increasing by 2.6%? 1.026, because you take 100 plus the 2.6% for 102.6%, or 1.026. Now, how do you figure out your population after 7 years? Just plug in 7 for x into your calculator and get your answer. Guys, watch your order of operations, too. Don't multiply this together and then raise it to the 7th power. That is wrong. You do PEMDAS, okay? Raise this to the 7th power first, then take it times 6,000, or just put your parentheses in the right spot and do it all in one step. Okay? Anybody do it, just so I can write an answer here for the video? 4,990. Okay? I don't know if it's people, I never really specified, but we'll just say people. 4,990 people. Round to the nearest whole number. Yeah. Okay? Alright, so a couple story problems.
You always give the